Welcome to this explainer. Today, we're going to do something I find absolutely fascinating. We are going to completely decode the periodic table, and along the way, we'll connect the rigorous integrity of science with biblical morality. We're essentially taking these huge abstract concepts and turning them into incredibly practical, life-guiding knowledge. So let's jump right in. Right off the bat, let's tackle this massive question. If you look at the periodic table as just some random poster of letters, it's pretty overwhelming, right? But we need to totally reframe it. The periodic table is actually a map. It's a map of hidden, predictable patterns. And by learning to read this map, we can literally predict explosive chemical reactions perfectly and safely, long before anyone even picks up a test tube. Here is our roadmap for today. 1. Decoding the periodic table. 2. Graphing the atomic trends. 3. Patterns down and across. 4. Why atomic patterns matter. And 5. Education grounded in morality.
Okay, Section 1. Decoding the periodic table. The what behind the elements.
You know, this ancient directive to examine everything carefully perfectly sets our foundational mindset for everything we're about to do. Careful examination honors truth in science. In our context, that means we don't just guess. We check credible sources, we plot our data correctly, and we draw fair, honest conclusions based strictly on what is actually there. So before we start crunching any numbers or tracking trends, let's lock in two crucial definitions. First up, atomic radius. Simply put, this is the physical size of an atom, and because atoms are unimaginably small, we measure this in picometers. Second is reactivity. This just tells us how easily an element undergoes a chemical change. For example, how easily a metal in group 1 might lose an electron and cause a massive bubbling reaction.
Moving right along to Section 2, graphing the atomic trends. This is the how of our paper and data lab.
Instead of handling dangerous, highly reactive chemicals right off the bat, we can actually conduct what's called a paper and data lab. We do this by following 3 totally safe practical steps using published atomic data. First, we pick a vertical column, like group 1, and write down the atomic numbers and radii for elements like lithium, sodium, and potassium. Next, we do the exact same thing for a horizontal row, let's say period 2, from lithium through neon. Finally, we plot this out on 2 graphs, comparing the atomic radius versus the atomic number so we can discover the visual patterns ourselves. By pulling published values from trusted references into a really clean, organized data table, kind of like this one for Group 1, we completely prep our facts for accurate graphing. Notice how lithium, sodium, potassium, all the way down to rubidium and cesium are mapped neatly by their atomic number. This kind of organization is literally the bedrock of good science. And wow, plotting that data reveals a completely undeniable pattern. Just look at how the size of the atoms steadily grows as we move down the group. Lithium is small, sodium is medium, and potassium is larger still. You don't have to guess at all. The data paints the picture right in front of you.
Section 3. Patterns down and across. Analyzing our findings.
The really crucial point here is visualizing this exact contrast. When we go down a group vertically, atoms get bulkier. Why? Because we are physically adding entirely new energy levels to the atom. So naturally, cesium is going to be much larger than lithium. But here's the twist. When we move horizontally across a period, from left to right, the atomic radius typically decreases. It shrinks tighter. This happens because the nucleus is getting a stronger positive charge, which acts like a giant magnet, pulling those surrounding electrons closer in. That is exactly why fluorine is actually smaller than carbon.
Understanding those size differences naturally brings us to a really fascinating question. How does the physical size of the atom actually connect to its chemical reactivity? Like, why does throwing potassium in water cause a way bigger reaction than lithium?
Well, the answer comes down to simple physics. A larger radius means that the outermost electron is sitting much, much farther away from the center of the nucleus. Because it's so far away, the nucleus just doesn't have a strong hold on it. It becomes incredibly easy to remove. And for metals, easier electron loss directly results in a highly reactive element. So, the bigger the atom gets as you move down that group, the easier it loses that electron and the more violently it reacts.
Section 4. Why atomic patterns matter. The why of scientific analysis.
Spotting these trends transforms scattered, random facts into incredibly usable knowledge. Let's break down why this matters. First, looking at data yourself builds real confidence. It completely beats just guessing. Second, it ensures your safety by helping you avoid dangerous assumptions about chemicals. Third, mastering this prepares you heavily for high school science and future technical careers. Fourth, it seriously enhances your communication, teaching you how to build rock-solid lab conclusions using the claim, evidence, and reasoning, or CER format. And ultimately, verifying claims with credible data empowers you to be a smart, informed citizen.
Which brings us to Section 5, Education Grounded in Morality, the Beyond.
Remember earlier when we talked about examining everything carefully? Well, true scientific wisdom requires absolute integrity. It means we practice the discipline of reporting what our data actually shows, not what we were kind of hoping it would show just to prove a point. We use these factual discoveries to care for people, keep others safe, and protect the world God made.
This aligns perfectly with the core philosophy of the Hero Smart Academy Godly Learners series, which is that education separated from morality will ultimately cause harm. Really think about it. What is the point of being incredibly smart and highly educated if you just continue to make bad choices that hurt yourself and the people around you? Intelligence without character almost always leads to destructive choices.
But there is an alternative. When we successfully blend our rigorous scientific education with deep spiritual mindfulness, we unlock something profound, a genuine peace of mind. As promised in Romans 8, this isn't just a nice thought. It's something we consistently experience and deeply want to share with you as you continue your own educational journey.
As we wrap up this explainer on atomic trans and data integrity, I really want to leave you with this provocative thought to ponder. If you have all the knowledge in the universe to perfectly predict chemical reactions, but you completely lack the moral character to use that knowledge safely and for the good of others, what is the point of learning at all? Thank you so much for joining us, and keep examining everything carefully.